What up, dudes? All right, so check this out. Here's what my plan is. I wanted to move on to chapter Rat 3, so Rational Functions Part 3. But, you guys seem to have been having some trouble on Rat 1 and 2. So I think what I'm going to do today is I'm going to go over Rat 1 and 2, and if I have time, I'm going to go over Rat 3. If I don't have time, I'm all right. I will be finished today by 1:30, and I can cover Rat 3 on Friday. So what's nice is, we're only doing short classes. I can just basically say, okay, we're going to scratch what I wanted to do and cover that on Friday, and then I'll cover Rat 2 on Rat 1 and 2. And particularly, it seems they're having trouble with Rat 1 and 2, or 1 over 2, right? All right. Yeah, we'll be finished at 120-ish. That sounds good to me. Okay, and I sent out an email to a few of you saying that I'm really concerned about your grades. Let me know please keep up with your grades. Is that possible? You guys are going to be able to do that, right? I need you guys to make sure that you're attending class, that you're logging in, because I'm sending all this information over to the admin side, and I don't want you guys to get in trouble, but I want you guys to keep up with your grades and whatnot. So I sent that out to you, and I guess I sent it to just you. If not, I'm gonna have to move on and talk to your parents and whatnot. So, all right. Now I have a question. Are you guys struggling with Rat 1? The concept of it? Are you guys struggling with the idea of it? Or just those specific problems? Do you guys... By the way, but the way it's done. Okay, all right. I struggle with solving solving the problem. Okay, mostly the problems. Why don't I go over a few problems that I printed off the internet, just so that we can get the idea of what we're doing, and then what we can do is we can we'll go and actually do the problems that are inside of the thing. And I'll tell you what. Of the 5 problems that Jenna did, why don't I do 3 of them with you guys, and we'll cover those. Sounds good? All right, cool. So let's start recording this thing. Let's start up over here. Can you guys see me all right? Is this correct? Does it say hello? Yep. All right. I just want to make sure that you guys don't have this thing backwards. Can I make the webcam bigger? I thought I did. If you guys want to change the webcam size, on the bottom right hand side, there's a little drop down menu. Click on webcam meeting. I think that the first, what you'll see, there's like home or something like that, or main screen or whatever. Drop that menu down on the bottom right hand side of this conference. Click on webcam meeting. That should be able, yeah. That should make it all nice. So in the future, you guys don't need me to do that for you. You guys can do it yourselves. Let's try this one. Let's try this problem on for size. How's about x squared plus 8x plus 12 over x squared plus 3x minus 18. Now, if I asked you to factor the top, that's pretty easy to do, right? And I would have asked you to factor the top. This was back in, I forgot when we covered this factoring stuff. This was a while ago, right? But you get the parentheses, and you get an x over here and an x over here. I know this is going to be a plus and a plus. And I know that, let's see, 12. Can I think of 2 numbers that multiply out to be 12 that add up to 8? 6 and 2, very good. Okay. Now, I'm going to tell you this off the bat, that when I factor the denominator, I'm going to go and factor the denominator. This one is easy enough to just factor straight ahead without any hints. But here's what's going through my head. is I'm thinking that in the denominator, we're going to have an x plus 6 in the denominator, or we're going to have an x plus 2 in the denominator. Because if there were an x plus 6 over here, then that would cancel those things out. Or if there was an x plus 2 on the downstairs, that would cancel things out, and I'd be happy, right? But I just want you to keep that in the back of your head when we're actually trying to solve this and plugging in the numbers. So let's try to plug in the numbers and try to solve it. So x squared plus 3x minus 18, I'm just going to put an x and an x. Since there's a negative here, I'm thinking that there's going to be a positive and a negative. And then I have to think what numbers will subtract from each other to make it to be 3. But they have to multiply through each other to make 18. And I think that Lucas is exactly right. This one is a 6 and this one is a 3. I almost had a tendency to even want to put a 6 there without even, without calculating it in my head. Do you guys see how this ended up working out nicely for me? All right. So then what we're going to do is we can cancel this out and we can cancel this out. So your answer is x plus 2 over x minus 3. You can cancel out if it's in, like if it were like 3 times x over 4 times y. No, wait. Let's make this 4 times x. You could cancel out the x's like this. You can cancel it out mainly if you have the stuff in parentheses over here matching the stuff in parentheses downstairs. Does that make sense to you? All right, cool. So my simplified rational expression of this is actually that. But not when the x is alone. Is that what you're saying? What I'm asking you is, Lucas, are you saying something like x over 5 plus x? Can you cancel the x's out? No, absolutely not. You cannot cancel the x's out. However, if you had something like this, x over x times 5 plus x, then you can cancel these x's out. You got it? So you can cancel that out of the numerator and the denominator if there's like a plus sign or a minus sign in between them. But if this thing is pulled out and this thing is multiplying this whole thing, then I can cancel that out. Then I can cancel out those x's. And my answer would be 1 over 5 plus x. Does that make sense? Okay. I'm going to try a couple more problems, and then I'll tell you what, at that point, what I'm going to do is I'm not even going to pull up the homework. I want you guys to tell me the problems you want me to solve. You guys just type it into the thing, and I'll solve them with you guys. See you, Andre. All right, let's try this one. Yeah, this would be good. 9x squared plus 81x over x cubed plus 8x squared minus 9x. Okay. Okay. Alana, I can answer that question. Why don't I answer your question with this, when I'm doing this one right here, okay? It's actually really easy, the A, B, C, D, E, F thing, all right? All right, so check this out. Before I start trying to factor something like this, right, I ask myself, can I pull out, is there something that is in both this term and that term? Can I factor out? I can factor out at least an x, I agree, and a 9. Do you guys see how 9 goes both into 9 and 81? So no one would argue with me if I just wrote a 9x over here and then I put, let's see, if I pulled out a 9x out of here, I would be just left with an x over here. You guys get it? And if I pulled out a 9x out of here, I would be left with just a 9 over there. Now, to double check, you can always distribute this 9x back in here and make sure that you get this thing back. But we're good with this, right? You guys understand how I was able to pull that out? Okay. I have a feeling that the bottom is going to have an x downstairs, or an x plus 9, or a 9. I have a feeling, because I mean, the goal is I'm trying to cancel these things out. So hopefully it has something like that. Well, first of all, I can pull out an x out of the bottom. There's an x cubed here, there's 2 of them here, and there's 1 here. I can pull out at least an x out of the bottom. Got it? Right, this is x cubed, remember? So if I pull out an x out of the bottom, I have x times x squared plus 8x minus 9. Because I dropped everything down by an x. I divided every term by an x. If I were to distribute this x back in here, it would be exactly that. You guys see how this works? All right. I can continue to factor, so let me just kind of continue on this board right here. I've got 9x times x plus 9 over, that's just the numerator, I didn't change it. And then over here, I'm going to factor that. X, and I think that Jenna already came up with the answer for that. That was x plus 9, x minus 1. There we go. Yeah, exactly. Which is good. I'll tell you, to be honest with you, I kind of had it in my head that there was going to be an x plus 9 downstairs. So I can cancel out this x plus 9 over here. Now, here's the thing. Can I cancel this x and this x out? No. But can I cancel this x and that x out? See this one right here? This thing's pulled out of the parentheses. This one's outside the parentheses. We can kill those. So my answer is 9 over x minus 1. Now, Alana, the question that you're asking is, what is this A, B, C, D, E, F, G business, right? And that goes back to like when I asked you guys to, do quadratic equations, and I'm asking you guys to write down, like, your answer comes out to be like 4x squared plus 2x minus 7. What is A, B, C in this case? Do you guys remember way back when we were doing quadratic equations? A is 4, B is 2, C is -7. Yeah. Alana, does that confuse you in any way, shape, or form? No. Okay, good. The answers to these rational functions can look, and the reason why I'm doing this is because I said, well, compare that to ax squared plus bx plus c. What did a need to be, what did b need to be, and what did c need to be to match that equation exactly, right? You understand this game. I think that on the homework, what I asked you to do is the answers could be as ugly as ax squared plus bx plus c. Actually, I think it was like ax cubed plus bx squared plus cx plus d. Did I do all the way up to d? I don't remember. Anyway, I think it was like the answer could be as ugly as ax squared plus bx plus c over dx squared plus ex plus f. Now, how does that translate to this over here? Well, how do I indicate just the straight up number 9 in the ABC format? C is 9, A and B are 0, right? A is 0, B is 0, C is 9. That's it. And then how do I indicate x minus 1 in the DEF format, which is just like the ABC format. I'm just using different letters. E is 1, F is negative 1. Very good. And D is 0 because I don't see an x squared anywhere in the denominator. So if I were to ask you to put this particular answer in ABCDEF format, it would just be like C is 9, E is 1, F is negative 1, and everything else is 0. Does ABCDEF format make much more sense to you now? Yeah, it's really just that I don't know how to ask you to type that into the computer. So in order to kind of get you guys to do that, what I did was I had to come up with this idea here. All right. Yeah, it's 9 divided by x minus 1. That's the answer. Yes, you're right. Okay. Now, the only other complication that I think you might have, Alana, is that what if the answer was something like, what if my final answer ended up being like x plus 2 over x minus 1 times x plus 3? Like I couldn't cancel out any of these things. Okay? Then what I would have to do before I got my ABCD answer is I would have to put this in standard form, because this is in factored form, the denominator. So then the top is still x plus 2, but the bottom is x squared plus 2x minus 3. I just FOILed that on the bottom. You guys see this, right? You sure? I might have skipped steps real quickly. Just want to make sure you guys saw it. All right. And then, in that case, A would be 0, B would be 1, C would be 2, D would be 1, E would be 2, and F would be negative 3. And you're just reading it straight off. A, B, C, D, E, F. Does that make sense? And again, I came up with this format because I didn't know how to tell the computer to grade when you typed in something like this, because you don't even know how to type something in like that. But I can tell the computer, hey, A is 0, B is 1, C is 2, D is 1, 2, negative 3. And then the computer can be like, oh yeah, he got it right, or they got it right, and that kind of stuff. Usually this ABCDEF thing is not really a math thing. It's just we just came up with it because of this online education. If I were having you guys write your homework down and having me grade it, I would be able to look at that immediately and say, oh yeah, you got the right answer. In fact, you wouldn't even need to go through this step. You could just give me this step and I'd be like, I'd prefer this one actually. But we're an online school, so we have these limitations that we have to figure out how to get around. We cool? All right, I'll tell you what, at this point, I'm pretty much covered. I mean, I've got a lot of these problems, and they're actually pretty easy. I think the only thing I didn't cover with you is like how to divide and how to multiply these things. But at this point, why don't we do this? Why don't I just take your questions, pull up a question that you have, and I'll write it down and I'll solve it for you. But it's going to be your job to go into the quiz and take a look at it. All right, Jenna wants to do this one. Negative x squared minus 10x plus 25, all divided by 10x minus 100. Well, there's a negative in front of the whole thing. Okay? And is that times x minus 10 over 45 minus 9x? Is that what you were telling me? All right, do I have this correct? Because it makes a big difference if I don't have this written down correct. Do I have it written down correctly? Yeah, and then they're asking what homework is this from. Okay, all right, good. Okay, you ready? Let's do it. I'm going to go through and factor everything I possibly can. Let's factor the top. X, X. I'm thinking minus 5, minus 5. What are your thoughts? Yeah, all right. I still got that negative out in front. Don't forget that. I'm thinking I'm going to pull out a 10 out of this thing. So I have a 10 times a x minus 10. We cool with that? And I still got the times x minus 10 over here. Over, I think I'm going to pull a 9 out of here. And I'll have 9 times 5 minus x. Are we cool with that? Now, this one's going to be a little bit tricky. And I realize where there could be a mistake. I could see where you guys are having trouble with this. This obviously will cancel out with that one. Now, I kind of want to cancel out this x minus 5 with this 5 minus x. But, yeah, actually, Jenna, you're exactly right. I can't cancel it out in the form that it is in right now. But would you guys agree? Now, this is a trick. Would you guys agree to this? This is a side note. Side. On the side, think about this. 5 minus x is the same as negative x minus 5. Try distributing that negative into there. This would be negative x and positive 5. Hey, that's positive 5 minus x. That's the same thing. You guys see how that works? I mean, it's kind of a trick. So I can actually change this. I'm going to erase this. I can change this 5 minus x to an x minus 5 as long as I include an extra negative 1 in there. You guys get it? Because here, that's that negative 1 right there. I just made sure. And I put the parentheses around the negative 1 because I didn't want to think of it as minus 1. Math is all about being careful with these things, so I'm trying to be careful here. All right. So I can at least cancel out one of these x minus 5s on top. In fact, I can even do this. Watch. This negative right here, you can kind of think of it as a negative 1 up on top, right? That's the same thing. So I have a negative 1 divided by a negative 1. That cancels out that. So I would have to venture to say that my answer is x minus 5 over 90. When the dust settles and the smoke clears and I've killed off everything I possibly can, I still have an x minus 5 on the top, and I still have a 10 and a 9 on the bottom, which of course I'm multiplying together, all of this stuff together. So I would say x minus 5 over 90. I cannot divide the negative 5 by 90. You're right, I can't do that. Lucas, that actually goes back to your other question. X over x plus 5, you can't divide out the x's. Just like I can't divide out the numbers because there's that minus in the middle there. So I would have to venture to say, now hopefully I got this right and hopefully I put the answer in correctly, but I would have to say that the answer is simply, if I compare it to ax squared plus bx plus c over dx squared plus ex plus f. Alana, I want you to tell me, what is the answer? What would your A, B, C, D, E, F be? A is 0, B is 1, C is -5. I agree. And then D, E is 0, and F is 90. Exactly. There we go. I like your question, Lucas. What can you divide? You can't really divide things when there's a minus and a plus in between them. That's why we factor everything down, so that all right, here, I'll tell you what. Can I erase this? Okay. I'm going to go back to 4th grade math. And when we did 4th grade math, we did something like 4 times 5 over 25. Actually, here we'll go. We'll put the 5 down here and the 25 over here. And we'll do 12 here. Okay? And you kind of had to go, all right, this 5 gets canceled out. You kind of go like this. You kind of say 4 times 5 times 5 over 5 times 4 times 3, right? This is back in 4th grade, right? And you can say, well, this 5 cancels out with that 5, and this 4 cancels out with that 4. But you couldn't play this canceling game until you've broken everything up into their individual packages. Right? Because I could have done this. I could have said, all right, well, this is 100, or this is 75 plus 25 divided by 60. That's actually exactly the same thing. 4 times 25 is 100, which is 75 plus 25, and then 5 times this is 60. So then you would go through, you would say, okay, well, that's equal to 100 over 60, and then we were able to reduce that to 5 over 3, right? Do you see what I'm getting at here, Lucas? But I can't go and divide 75 by 60 and 25 by 60 and say and then say we're good. Or no, here's the thing. I cannot go and divide 75 by 60 and just add 25 to that. Say that I'm only going to divide that 60 into this first number. That is not fair. That is bad math. And Lucas, I kind of have a feeling that that's what you keep on coming back to asking me. And when you see it like this, you realize, oh yeah, that was bad math when I was a kid. I would have gotten slapped upside the head if I did that kind of mistake. Yeah, it's a package deal. Now, you can divide it after you've added it together. 75 plus 25 is 100, and then divide it. But check this out. If I had x plus 25 over 60, you can't just say, oh, okay, well, that's the same as x plus 25 over 60. Even though if you listen to the words that came out of my mouth, I said the exact same thing. X over 25 plus divided by 60 is not the same as x plus 25 over 60. It's because you have to add these together first before you divide it. The problem with x plus 25 is that's as simplified as you can get it. You don't have something pretty like 75 plus 25 is 100. You just have x plus 25. If I told you, what is x plus 25, you would tell me, get off my back. It's x plus 25. What do you want me to do? Right? So at that point, you have to just leave it. Are we cool? That was my tangent as to. Do you guys want me to do another problem before I leave, or what? What is the excluded value of... Oh, okay, all right. So I think Mikhail is asking me about a rational functions 2 part, and that's a really easy question. I'll answer yours first, and then I'll answer Jenna's right after that. This one is pretty easy. 6x minus 3 over x plus 2. Is that correct? Okay. Rational 2 is really all it is it's about vertical asymptotes. And watch my lecture on that so you can kind of see. Yeah, this is RAT 2. But if you go back to, I think I covered this in quarter 1. Or not quarter 1, but I covered this in like December or November last semester. We talked about what did we talk about? Oh yeah, we talked about domain and range. Do you guys remember me getting all like, whose domicile? It's my domicile, all of that kind of stuff. And one of the big rules of domain is there's no zeros in the denominator, which is why there's a vertical asymptote wherever there is a number that makes a zero in the denominator. That's what actually ends up happening. So all you got to do is you got to circle the denominator, and you got to say, well, x plus 2 cannot equal to 0. Cannot equal to 0 is equals with a slash through it. And then all you do is you just say, okay, well, you treat this just like an equal sign, but it's equal with a slash through it, and you say equal is not equal to negative 2. So x is not equal to negative 2. So what is the excluded value of this thing? I don't care what the numerator is. Negative 2 is your answer. The denominator takes the cake. Actually, yeah, that's correct. Now, I have a question. Did I write this down correctly? Okay. Because I have a feeling that it might be a little bit like, I'll show you a small change that would make this problem very different. What if I did this? 6x plus 3 over, no, how's about this? What if I did something like this? 3x plus 6 over x plus 2. Okay, what is the not allowed value? What value is left out? Or where is there a vertical asymptote of this thing? Come on, you guys, answer. Negative 2. Okay, negative 2. Okay, wait. This isn't simplified. Before we move on to RAT 2, let's apply some ideas with, well, okay, Courtney, why are they saying negative 2? And my answer to this, I'm actually tricking them. They're wrong, by the way. But I think that the reason why they're saying that is because I told them that all you have to do is look at the denominator and set it not equal to 0. And then you just get the positive 2 and you put it on the other side and you get x is not equal to negative 2. But I tricked them because I'm a jerk. Sorry. Let's try simplifying this first. Is there a number I can pull out of this thing? 3. All right. Okay, now what? I can cancel. Very good. So actually, this right here was actually a secret code for the number 3. Is there a domain problem with the number 3? No, because there's no denominator. There's only a domain problem when you have two situations. When you have a denominator, you're going to have a problem with zeros being that in the denominator. And when you have a square root, you're going to have a problem with negatives being in that square root. But the number 3, that's straight up fair game. So see, simplifying actually took that domain issue out of there. All right. Now, I told Jenna I would do yours, and I apologize. I already did one of yours, so I'm going to do Lucas's, and then I'm going to be done because I want to start up my physics class. All right. X minus, no. All right. 2 minus x over 8x plus 6 minus 3x over 8x. Is that what you're saying? All right. Lucas, I'll solve this problem. Sure, no problem. I'm almost hesitant because it's almost too easy. The reason why it's not, I hate to say too easy because, I mean, that always makes people feel dumb, but it's almost like it doesn't have the trick that I would put in there. This is kind of an easier problem. The reason why it's easier is because the denominators are the same. If the denominators, on the other hand, were different, then it would be a little bit trickier of a problem. And I can show you how to do both of them. Why don't I show you how to do this one first, and then I'll show you how to do the other one. Hey, what's going on, Alice? Come on. Are you here for physics or algebra, or both?
Both.
All right, well, why don't you come on over here, hang out for the algebra. We're going to basically just finish off this one problem.
Okay.
And then we'll get started up on physics. All right, so since this is the same denominator, I can just take this numerator and add it to that numerator and keep it over that same denominator. This is just like what you did back in 4th grade where you were adding fractions. So you have 2 minus x plus 6 minus 3x. Are we cool? All right. You add like terms, so this would be 8 minus 4x over 8x. And then the best I could do is maybe factor out a 4. And I have 2 minus x over 8x. And then what I can do is, I'm thinking that you take this 8 and you make him into a 4 times 2. And you can cancel this out and that out. So my answer is 2 minus x over 2x. In that case, a would be 0, b would be -1, c would be 2, d would be 0, e would be 2, and f would be 0. Are we cool? All right, I gotta go, but I want to show you guys two more things. I'm going to change the problem up just a little bit, okay? I'm recording this, so I'm going fast. This problem would be different if there were a negative sign over here. There is a small thing you have to worry about doing. What you have to worry about doing is, since I have, what I do is, since I still have the same denominator, I can keep that same denominator, but I'm going to take this numerator and subtract this numerator. So I have 2 minus x minus 6 minus 3x. And most people write this down like this. But, can we get more time on this? If no, it's okay. I got a question. Somebody asked me if I could open up the assignment. Does that mean, what does that mean? Does that mean the assignment closed, or does that mean you guys used up all your 4 tries? Is 4 tries enough? Okay. All right, I'm going to ask you that question, but I'm going to answer Micaiah's question. Exactly, Micaiah. What happens is a lot of people subtract this thing over here, but what they forget to do is they're subtracting this entire numerator over here. That's why I like putting in the parentheses around here, and then I distribute this negative into here. I add negative, and then I distribute that negative into there. Because that means 2x, or 2 minus x minus 6 plus 3x. And that would make a big difference in your answer. So be careful if there was a plus here and a minus here. The other thing that you guys need to make sure that you're careful with is if these denominators were different. Now, I did solve a few of these problems where these denominators were different, and that kind of was a big key to it. Because you guys remember back in the 4th grade days, adding fractions was hard, but not if they were the same denominator. Adding fractions and subtracting fractions were harder if they had different denominators. Then you had to find the common denominator and all of that kind of stuff. I'll tell you what, I went through and I already gave you guys, I changed it from 4 tries to 8 tries. So those of you who used up your 4 tries should have another 4 tries to do it. I already gave you 8 tries. I think I didn't do that on page 6, so I'll go and change that for page 6. I won't give you more time because I think that I have the assignment closing by January 29th. So as long as you make sure you get in all of your tries by January 29th, you'll be good. Please know that I'm pretty understanding. So email me and let me know, and I'll try to see if I can accommodate what you guys are asking of me. Hey, if you guys are doing the work, and you guys just be like, I need more opportunities to do the work, to do more work, who am I to say that, no, you are not allowed to do more work? I'm fine with it, to be honest with you. For the most part, I'm going to give you 4 tries, though, and I think that you can do it in 4 tries. Because not all teachers are like that. In fact, I don't know many teachers at all that are like that. So I need you to also get good at producing quality work the first or second time. If I cancel out the denominator, would the denominator be 0? No. It's just like if I have like 5 over 25. If I divide both top and bottom and reduce this, then it would be, well, 5 divided by 5 is 1 over 5, not 0 over 5. Because you're not subtracting 5, you're dividing by 5. So just like that, the denominator won't be 0 because you could have like 4 over 2, and then you can say, well, I can, cancel things out, and then that would be 2 over 1. The denominator is not 0, it's 1. But I guess that could be confusing because you could get rid of the denominator and just make it 2, since the 1 is pretty erroneous. I don't want you guys to think in your head that there's a hard due date. What I want you guys to think in your head is that there's a due. What I want you guys to think in your head is that I better turn in my homework on time, like when the Mr. Dalday says to do it. And if I don't do it, then I better get it in within the next 3 days, because if not, and I sent out a whole bunch of emails to students already, I'm checking your grade every day. I'm going in and looking at your grade, and I'm sending you emails. I'm even keeping track of who's attending and when you last attended class, when you last logged in, how long you logged in for. And if you're getting a D or an F, I'm flagging that. And I'm sending emails out. And I'm going to be calling parents next step. Here's how you know what your attendance is. Log into class every day and you won't have to worry about it. That would be my answer. All right. I have to go. I got to start up physics class, and I told him I'd start at 1:30. All right, fine. Bradley, what is it? Go, go, go. Hurry up, quick.
Okay,